In this video, we're going to determine the dimensions of a rectangular solid that has a square base, and we want to maximize its volume. We're given its surface area is 150 square inches. Okay, so first thing we want to do, and this is the first thing I do for all of them if I can, is draw a picture. Okay, so let's go ahead and just make this rectangular solid. We've got, and now we have a square base. Now I've kind of drawn this so that it's kind of awful, really. Normally I do quite a bit better job. Oh, that's horrible. Let's go ahead and fix that just a little bit here. But normally you don't want to really draw something that's ideal. Because if you draw something that's ideal, you're going to be stuck in that thought of, okay, well now it has to be this. And well, it doesn't have to be. And so perhaps what I want to do is, rather than go ahead and keep this drawing, I want to go ahead and change it up just a little bit. It has to be a rectangular solid, but they never said what the dimensions had to be. Okay, and so let's go ahead and extend this down just a little bit so that way we can go ahead and not go through that painful realization that, oh crap, you know, it's really not, it's not really that shape at all. And so we start doubting ourselves. You don't want to ever give yourself a reason to doubt yourself. That's bad. Okay, now, according to this, it has a surface area of 150 square inches, and so surface area is equal to 150 square inches. And it has a square base. And so if we look at this, then we have S here and S here, and I'm going to call this L. Now L is the same for all of that. So let's go ahead and find the surface area of this, shall we? So the surface area is equal to, now we have this side, and its partner here is SL. And so if you really look around, they're all SL. So we have 4 SLs, and that covers the all the sides. Now top and bottom is just S squared, so plus, well, we have 2 of them. Okay, and so now if we set this, we have 150 is equal to 4SL plus 2S squared. Okay, well, let's go ahead and, let's solve for, if we can, let's solve for L. I think that's going to be the easiest. Okay, so let's go ahead and factor out an S here. And so if we do that, 150 is equal to, now I can pull out a 2S. Let's go ahead and pull out a 2S. That's going to give us 2L plus S. And so I'm going to go ahead and divide both sides by 2S. 2S is equal to 2L plus S. And I'm going to subtract S off. And so it's 150 over 2, whoops, the other 2, that kind of looks like a 2. 2S minus S is equal to 2L. Now I have to divide by 2. So as you can see, this can get very nasty very quickly. And so let's divide by 2. 2 and 2. And so that we get 150 over 4S minus S over 2 is equal to L. Okay, let's go ahead and get a common denominator and clean this up just a little bit here. So we've got 150, and if I multiply this one by 2S top and bottom, then I get minus 2S squared all over 4S is equal to L. All right, so now I've got L. Now why did I get L? Why would that have mattered? Well, because I need the volume, the maximum volume. And so again, it might be a good idea to just over here throw down that volume equation. The volume is equal to the length times the width times the height, which is S squared times L. And so now since we solve for L, then we have V is equal to S squared times 150 minus 2S squared all over 4S. Okay, so now we've got all that. Now how you want to go about this, that's entirely up to you. I'm going to go ahead and I'm going to take this S squared and I'm going to distribute it. So I have V is equal to 150 S squared minus 2s to the fourth all over 4s. And now I can kind of cancel stuff out. So that goes away. One of those goes away. One of these goes away. It makes it a 3. So v is equal to 150. And now I can decrease that to 75. Because of this, I can cancel out a 2 from here. So that gives me a 2 here. That gives me 75. This gives me 1. And so I've got what left is 75s minus s cubed all over 2. That seems like an awful lot to go through, but remember, I need something I can work with. And trying to take the derivative of this thing here would just, you got to use the product rule and then the quotient rule inside the product rule. Oh, it's horrible. So I'm just going to go ahead and let it be and do that little bit. Okay, now I want to go ahead and take the derivative with respect to s. And this is going to give me, now that the 1/2 can come out. And so the derivative is simply just 75 minus 3s squared. Set that equal to 0. 0 is equal to 1/2 times 75 minus 3s squared. Okay, so that's going to give us, well, we can multiply by 2 on both sides. And that's going to give us 0 is equal to 75 minus 3s squared. This is going to give us 25. If we subtract 75 and then divide by -3, this gives us 25 is equal to s squared, which if we solve for s is equal to plus or minus 5. Again, we're dealing with the length, and so all we need is the positive. So we found out the s is 5. Again, you can go back, you can take the next derivative of this. And so if you take the derivative of this, you're just going to leave, excuse me, you'll just bring this out, and then that'll go away. This will be -6s. Okay, so when you put a value in, like 5 for that, then you're going to have a negative value. And so that's going to be concave down, which is going to give this a maximum. So according to the second derivative test, we have a maximum, which is good because that's what we're looking for. So we found out that s is equal to 5. S is equal to 5. So now the question is, what is L? Well, we could go back through all this junk, or we could simply come back up here and say, okay, well, I don't know which is going to be easier. So I guess we'll just plow through. Just go ahead and plow through, I guess. 150 minus 2 times, well, that's 25, all over 4 times 5. This is going to be 150 minus 50 is 100, divided by 20, which is 5. And so L is also 5. And so you're looking at a rectangular solid of 5 on all sides. And so our initial assumption here that this was a cube was actually correct. Now, we don't want to keep doing that. That's bad because that will cause us to try to second guess ourselves. All right, so there we go. And that's how you do the volume ones. They're not that bad once you get into it.